Okay. Hey, good morning, everyone. We'll give just a minute to get the sound levels right. But my name is Adam Hesch. I'm a Principal Solutions Architect here at AWS. I support our federal partners, which is broadly category defining system integrators and other people who are doing work on behalf of the federal government for AWS.
Hey, and I'm Forrest Benton. I'm a Solutions Architect on our Worldwide Public Sector DoD Fourth Estate team.
And we're here to talk to you today about integrating AWS services and zero trust networks. At a high level, very high level, we're going to talk kind of an introduction. We want to introduce the idea of zero trust, what it is, what it isn't, mostly kind of what it is, and where at least we're going to think about zero trust. We're going to talk about network access use cases. So like what are the things that, from a zero trust perspective, that I might actually be doing with my environment. And then we're talking about some access patterns, kind of like what are the services, what are the patterns that you can implement in your architectures to achieve zero trust outcomes today. That's the abstract for it, and we'll go into a lot of different details along the way as we go. So we'll start out with why zero trust? Zero trust is the popular buzzword. It's all the rage right now. We have things like cybersecurity executive order. We have all these different reference architectures. But why do we want zero trust? What are the outcomes we're trying to achieve? When we talk about zero trust with customers, we're always trying to focus on the outcomes because it's like a journey. The zero trust isn't the destination. It's like the journey. It's delivering with security. And so the things that we want to achieve with zero trust specifically, we're going to start out with. We want to start out with the most fundamental thing, which is we want to protect against internal and external threats. We've long had the moat and castle, right? We have the crunchy outside, we have the soft inside, and that's kind of failed us over time. We've found that crunchy outside is not always necessarily as crunchy as we think it is, and we want to start to think differently about that. And like the most fundamental outcome that we achieve with zero trust is this idea of protect against both internal and external threats. We've moved beyond just thinking about the external threats. Now we need to think about the internal ones. And that could be literal internal threats, insider threats, and things like that. Or it could be things like EC2 instances with credentials that get popped, or firewalls with vulnerabilities. Like these are all internal threats because they've been able to make it inside that big outer perimeter. And now there's these opportunities for lateral movement and things like that. So one of the fundamental outcomes that we want to do when we're thinking about zero trust and like a zero trust transformation is think about how we're going to address those things. One of the next pieces, and this is kind of a misnomer, you don't think of this, is scalability. When COVID happened and we all got sent home and we all hopped on our laptops, and then the VPN concentrator started falling apart, right? The network started falling apart. If we're not taking scalability into this and thinking about scalability as part of our zero trust journey, we're doing ourselves a disservice when we're thinking about the future. Because we need to think differently about zero trust. And this is one of the things I talk a lot with customers, is like, what are the outcomes? What's the business use case associated with it? So we have to start with that being a component of this. We want to get away from single points of failure. We want to start thinking about how we can do this in a better, different way. And part of that different way is we want to have an improved remote user experience. If we have better security, but it's super hard for users, what do users do? They just ignore the security, right? They hop off the VPN and they use the internet. Or they can't get access to resources, so then they'll use Google Docs. Or they'll be using anything else. You know, they're going to find a way around the security. So if we don't make a better user experience, if we make a hard user experience part of the zero trust journey, then people are going to find a way to do it wrong. And that's for our users, and that's for our professionals, right? The easiest way, if the easiest way is the most secure way, that's going to be the thing that people are going to do. So we have to make that like remote experience better, and we need to make it more scalable so that we can kind of get things going. And then the one that's probably part of this is one of the big components of zero trust is we want to know that what's on our network is like secure by default. Or at least if it's not secure, we want to make risk-based decisions related to it. So we know it's a managed endpoint, or it's an unmanaged endpoint, or it's something else on our network. It's okay. It doesn't all have to be completely secure, but then we can take that into our decision process, and we can think about how we're going to use that as part of like our zero trust considerations. So now that I've talked about zero trust a bunch, one of the things I want to show is like, hey, where are we going from? Where did we start to where are we going to? So if we look at our legacy network architecture, this is probably familiar to anyone who's kind of operating in AWS today, which is We have our remote users. They might be accessing AWS via something like a VPN. That's going to go to a layer 3 VPN gateway. If they're on our on-premises network, they're going to be coming through Direct Connect, potentially to some sort of ingress point. And then we're going to have our DMZ. We're going to have that crunchy outside, that layer 7 firewall that might be doing some sort of traffic inspection. Maybe it's a lower layer and we're doing IDS, IPS functions. This is kind of what we're working with today. And what we don't want to do when we're thinking about zero trust is this. Now I have my zero trust network architecture, right? I'm no longer using a VPN gateway. Now I have a software-defined perimeter and a micro VPN. And I'm no longer using a firewall. I have an identity-aware proxy. Have I fundamentally changed my security whatsoever? Or have I just fundamentally changed the marketing and terminology? That's a key component. If we just continue to look at it as products, the bits and pieces, we're not going to achieve the security outcomes we want. Because that right-hand side of the picture is where people tend to really get into problems. When we talk to customers, we work with customers, it's not Adam in accounting's laptop that's the thing that's usually causing the security issues. It's that right-hand side. It's the firewall with the vulnerability. It's the instance with the misconfigured role that start to allow lateral movement. These are the things that generally are the difficult things to secure. So we want to build security in on the right-hand side so that we can achieve these outcomes. And we can have good security, secure by default, in a zero trusty way. One of the things we're going to talk about next is kind of that usage pattern. And this kind of goes into when we look at a little bit later on at the different ways that we address these patterns. But fundamentally, when we're looking at our usage, we're going to start out with our user. And our user is going to be using some sort of device. Now, it could be a laptop, could be a desktop, could be a phone, could be managed, could be unmanaged. We're going to talk about these in broad terms, and then that's all just goes into your decision process. That device is going to be residing on some sort of network. And we're going to talk about how you might consider what that network is. Is it the coffee shop? Is it the on-premises network? Is it their home network over VPN? Could be any of these things. Again, all important data points into zero trust, but none of them are going to give us any particular, like the network alone no longer is consideration. This is a networking talk. It's Network 301. The network is not dead from a zero trust perspective. The networking is just now a data point that we use in our decisions, as Forrest will talk about. And we're trying to access services. It could be our human resources application, could be our ERP, could be many things. This is what users are trying to get access to so that they can get their data. Again, could be documents, could be databases, et cetera. These are the usage patterns. And along the way, we need to think about each one of these different components and then think about how we're going to provide zero trust mitigations, how we're going to think about the different ways we can provide security at each of these levels based on the risk profile present. And the last thing we can't forget about is zero trust in the modern network is not just users and services anymore. We have thermometers, we have IoT devices, we have cameras, we have HVAC equipment on our networks now. If we're not thinking about how those are part of the problem so we can come up with solutions that encompass them, then are we really addressing the zero trust needs? One of the nice things with this usage pattern that I really like, and this is our DC Summit, so it's kind of focused on our public sector customers, is it lines up really nicely with what is the Department of Defense Zero Trust Reference Architecture. The DoD did a really nice job of defining these pillars that line up to those usage patterns that we think about with our users today. So if we have users that are using devices that reside on networks to access applications, to then access data. And then one of the things they take into account is they then look and say, hey, what's the automation and orchestration that can be facilitating these things together? And then they also say, what are the visibility and analytics? How do I know what's happening from point to point to point? How do I know what's happening from what the user profile looks like? Where are they coming from? What does the device look like? What's the status of it? The network that they're residing on, the application they're trying to access, the data. I'm feeding that into my visibility analytics, and then I'm also feeding it back into my policy enforcement point and decisions, which is kind of a NIST concept that we'll talk about a little bit later. But we really like these pillars in terms of what they deliver and how they kind of frame the conversation. Because I think before I came in, someone said, hey, what are you doing a talk on? I said, zero trust. And they said, so there's going to be 14 different answers or 14 different ways to talk about that. You talk to 14 different people here, they're going to give you 14 different answers on what Zero Trust is. This is a really nice way of encompassing all that. It's all Zero Trust, but it's all different aspects of Zero Trust within the pillars. But as I said, this is a networking talk. So specifically, Forrest and I are going to be drilling very heavily into this particular pillar, which is that network and environment, which is what can you do with your network to achieve Zero Trust outcomes on AWS today? And they break that down into four further subcategories that we've kind of bulleted our talk into. And so we're going to start out with a software-defined network. What do we do to deliver quality of service? Then we're going to talk about macro segmentation. Now, how do we break that traffic at the highest level and then look at technologies later? We're going to go application delivery. What's the new DMZ look like in a Zero Trust way? And then micro segmentation, which is we get all the way to the right-hand side, and where do we go from there? So with that being said, that's kind of the intro to our topic. And now we're going to dive into these individual aspects, and I'm going to hand it over to Forrest to talk to you about software-defined networking.
Thanks, Adam. Yeah, software-defined networking, it's not a terribly new concept. Right? We've been dealing with it on-prem. We also deal with it in cloud. Right? It's really fundamentally about direct programmability of our networks and about decoupling network from the underlying hardware. It's providing us a lot of agility as network administrators, right? But it's also providing us a lot of visibility, which is important as Zero Trust network architecture, understanding where your network is and what's on that network. A lot of SDN technologies are supportive of that. Now, to go further, that this is complementary to Zero Trust, particularly in a world where you have distributed IT assets. As Adam had talked about, you want scalability. You have endpoints everywhere now. Leverage software-defined networking capabilities alongside Zero Trust cybersecurity, right, to secure endpoints wherever they are. Oh, I'm a little fast. Give away the towel. All right, so if you've worked in AWS for a while, right, you're probably familiar with a number of our networking services. Virtual Private Cloud, or as we call it, VPC for short, has been around since 2009. And this is a foundational service for our public sector and private sector customers, offering you the ability to deploy a logically isolated network in cloud. Right? This is all, just like any other AWS services, controlled via APIs on the AWS control plane, offering you the ability to spin up new VPCs, right, at a whim, to deploy subnets across availability zones in a region, to attach and detach gateways to connect to different networks, be it public or private. Really a powerful capability, right, to build your cloud-based solutions. In 2018, we introduced Transit Gateway. As a member of our DoD team, this is one of my particular favorite services. This is a region-scale, highly available router that provides customers the ability to stitch together hundreds and even thousands of virtual private clouds. It simplifies very complex, very segmented networks in the cloud into a simplified but highly available hub-and-spoke model. And with support for other attachment types, like Direct Connect and site-to-site VPNs, right, we have extensibility back to on-premise locations. The later attachment type we added was Transit Gateway Connect. Connect gave a lot of opportunity for on-premise customers managing SD-WANs on-prem to extend seamlessly that capability into cloud. Transit Gateway Connect supports generic route encapsulation, or GRE, and border gateway protocol, BGP, right, allowing you the ability to dynamically learn about vast topologies in cloud and to orchestrate it through SD-WAN appliances that you bring into the cloud. So this creates a compelling story end-to-end, right, for virtualized networking. And when leveraging technologies like SD-WAN, you can introduce policy as well and get away from just thinking about IP addresses and protocols, right? Even in some cases, thinking about users and user groups, right, and route efficiencies across this fabric. Routing HR users, right, directly to their applications wherever they are, right? But leveraging policy to keep users separated from one another and keep their applications separated from one another here. End to end, it's a very compelling story, right? But ultimately, this is not a golden architecture. This is not a reference architecture that everyone in public sector, DoD, federal space necessarily needs to be building towards, right? You need to think about what your mission needs are, right? How best to achieve those with software-defined networking, with the Zero Trust concepts and segmentation concepts we'll talk about today. So as we go through these next sections, macro segmentation, micro segmentation, application delivery, we're going to go through really a laundry list of techniques and technologies that may or may not all be applicable to you. Right? Think about how you're building today. Right? Think about your security needs, your compliance needs, and build towards that. But what we want to show is a number of methods, right, in which we can begin implementing against these networking constructs. The first I'll start is with macro segmentation. I think this is probably the most familiar, right, of these kind of methods. This is about applying network segmentation with a methodology towards broad-based rules, right? Thinking which business units need to be able to communicate to one another, right? Which resources talk to one another? How do I prevent lateral movement at an enterprise level, right? We're thinking very coarse-grained here, a bit of a blunt instrument, really, right, in our segmentation. And so, like I said, Transit Gateway, one of my favorite features of VPC. We work with these a lot in public sector, right, because it really simplifies the ability, right, to build out in cloud. And when Adam and I talk about macro and micro segmentation, we typically think of the dividing line between the macro and the micro beginning somewhere around the perimeter of the VPC, right? And as Adam will get into about best practices that we adhere to, right, we think of a VPC as being suitable only for one application or one environment per VPC. So I could have an environment or an enclave right here with an ingress-egress point, and I can stitch these VPCs, these applications together, segment them off into their own VPCs, and attach them, right, to a unified network, right, but provide segmentation between these applications. In moving outwards, right, I'm going to enforce further macro segmentation with the way I manage routing on a service like this. Leveraging route tables in a transit gateway, right, I can have distinct route tables that I apply in a one-to-one or one-to-many fashion with my attachments. That can be your VPC attachments. It can be a direct connect attachment, your site-to-site VPN attachments. Right here, we'll just focus on that VPC. So in my case, right, I have an enclave that handles relatively all the same sensitivity of data. But I know, right, in VPC A, where application A is, right, I have VPC B with B and so on. I know in application A and VPC A, right, that it has no business talking to what I'm doing in VPC B and VPC C. And I want to keep that separation. I want to prevent any type of unnecessary communication in my environment, any type of lateral movement that I know there's no justification for. And so to do that, right, in this case, I might associate a specific route table to that attachment in a one-to-one fashion. Make explicit rules in my route table that says, hey, if application A ever tries to talk to B or to talk to C, I want you to drop that packet the second you receive it. Right? So as traffic enters into the transit gateway from that VPC, this route table is referenced. Right? I can make those rules. Right? I'm going to provide it, right, access still to my enterprise WAN, access to the internet. Right? I'll provide a common egress path out and provide what we call kind of our quad zero route, 000/0. Right? But then I'm going to leverage this totally separate route table in that transit gateway. I'm going to associate that in a one-to-many fashion with my highly collaborative VPCs here. B and C talk to one another quite a bit. I'm going to provide them routes to one another, and just like I did with VPC, I'm going to provide that common route out. Now, you might also be managing security stacks today, right? If you're in the public sector. You've got a number of appliances you're familiar with that you like using. Right? You may also have a need to understand what's going on, right, between VPC B and C. I'll write all of my allow and deny rules in a centralized inspection VPC, and I'll decide where traffic can go. But even if I allow that traffic, I want to know what VPC B and C are talking about. Right? I want to see that. I want to log that. I want to monitor it, inspect it. Right? So we can take a path like this, where all VPCs have a default route out to that inspection point, and I can leverage the appliances that I leverage today, right, to make those decisions. Zooming out from a VPC, think about also how you handle ingress. It's very common that we work with organizations that have both low and high impact systems. Right? It wouldn't be appropriate to funnel low impact data potentially through the entry point to a high impact system. That's true even in a non-zero trust world. Right? So in this case, think about how you actually want to divide out those front doors. Right? If you have internet users hitting a public-facing load balancer to an employee directory app, that's fine. But you may require, right, users be on a certain network segment to access that resource app. And I think this is actually what's really counterintuitive. Right? I'll give you a more zoomed in view here. Right? This is kind of a similar design, but more of a hybrid approach where I have a public load balancer allowing internet access. That feeds into a private link interface. Adam's going to talk about how this functions, how we secure it. But it's actually providing access to a VPC that has no direct connectivity bidirectionally. Right? Same as below. But like I said, this is kind of counterintuitive. And why is that? Well, you might look at this and say, well, hold on. I have a remote user on the internet. They come in through an ELB, right, Elastic Load Balancer. They get access to an employee directory app. But then I have a network user on the corporate network. And for some reason, that user has greater access, greater privilege to this environment. That doesn't seem very zero trusty, right? I mean, that seems like we're placing trust on a network segment. But we're told not to do in a zero trust world. Like Adam said at the beginning of this presentation, we don't believe that networking is dead in a zero trust world, right? It's a data point, it's a decision point. It can be part of a requirement. So what if we say this? What if we try to square this topology with zero trust? How might we say that? Can we say that network location could be a necessary condition for access to an endpoint, but in a zero trust model, under no circumstances should it be a sufficient condition for access? I'm going to kind of take a step back. I know not all of you had to study for an LSAT like I have at some point. And necessary and sufficient conditions get me confused still. We have very valid means or reasons to leverage macro segmentation to deny access to endpoints, right? You'll go through a risk-reward process and decide where should my endpoint be to be most effective, to be most performant, right? But also, what kind of risks can I manage? What can I mitigate? What can I not mitigate? Right? You're going to make a decision around how you want to segment these types of endpoints. Right? Probably a lot of you in this room are leveraging something like geofencing today, right? You'll say, we just know that there are certain locations for which there's no valid traffic coming to this endpoint. And that's not at odds with zero trust, right? But what's critical to understand is that it doesn't mean because you're on the right side of that macro segmentation that that alone is good enough to access an endpoint. And the devil's really in the details here. We'll talk a lot more about these purple icons here, the elastic load balancer, security groups, private link. But the key thing to take away, right, is that this is a topology where we can apply zero trust principles, where we can apply or inject identity into the request path from this corporate network, meaning that just because the network user is on the corporate network doesn't mean that that alone is good enough to access my human resources app here in the bottom right. That leads me to application delivery. We really think of this in the zero trust model as really the decision point and the enforcement point, right, close to your endpoints. This is moving us away from basic layer 4, layer 3 style controls and can bring us all the way up to layer 7 in the OSI stack. If you haven't seen this diagram before, this is from the National Institute of Standards and Technology, NIST, publication 800-207 on zero trust. This is kind of an AWS-defined version of it. But I think a really good distillation of how to think about access at an endpoint and how to control access at an endpoint. When you think about application delivery, I kind of bucket these into 3 components. You have a policy engine, it's kind of your big brain. You get a policy administrator, also a pretty big brain, and you get your policy enforcement point. I kind of think of it as the bouncer, right, the muscle of this. Your policy engine, right, is designed to make decisions around allowing or denying traffic received at a policy enforcement point, right? So I have, in my case, Adam making a request to an enterprise resource. I'm going to place an enforcement point in front of that, right? I'm going to evaluate Adam's request using that engine. Right? And this engine can come to incorporate lots of different contexts besides just identity and attributes. Right? I might be looking at device posture. I might say, when was his last update on his OS? Right? What's the security patch status of his device in his browser? It might be evaluating his request against threat intelligence I've incorporated to say, does this look like anything nasty that we're seeing out on public networks right now? I may evaluate activity logs. I may say, Adam usually logs in from 9 to 5. Why am I getting this request at midnight from a different location than usual? Is that suspicious? I can leverage other forms of information here, ultimately to render an allow or deny decision. Right? And I'm going to hand that as a policy engine to my policy administrator. And that policy administrator is really the executor, the one that goes out and affects that decision. Right? It receives an allow decision by the engine, and it's going to go out and figure out how to make that happen for Adam. Right? Policy enforcement points I like to think of as being a series of valves. Right? And the administrator needs to figure out what valves do I need to open to get Adam to where he's trying to go. But how about we actually begin applying some of these concepts to, let's say, AWS native technologies? I think a really easy way for me to think of this is in context to something like an application load balancer. Right? An application load balancer we can set up actually an authentication step, right, and require authentication leveraging OIDC. Or not present here, Amazon Cognito. And this means, right, if Adam comes in again to my application, right, he issues a request to my application load balancer, my 443 listener, right, and that request matches a condition for my authentication rule, I redirect Adam to my OIDC compliant IDP. Right? And that's at that point where I can begin saying, all right, well, what does device posture look like? What are the attributes on Adam? Right? Did he log in via MFA? Does he meet requirements? And that IDP, in this case, is just going to provide an authorization grant code, right? We're using that type of grant type. We're not going to give him the access token or token ID directly, but we'll give him a code that he can then take back to the ALB. That ALB is going to grab that, and it's actually going to work between itself and the corporate IDP, right, to get that token ID, that access token. And it's also going to grab user claims, right? And it can provide that user claim as well as the access token back to your target groups as well. And it will sign those user claims, right, with a key that you can pull from a regional endpoint. Right? So that can be provided to your target here. And then I'll lay on additional controls, right? I'll look at AWS Shield, Shield Advance, to protect myself against unidentified endpoints on the internet, right? Attempting volumetric attacks against my ALB. I can apply a web ACL with AWS WAF on that ALB. But I'm terminating TLS on the front of that ALB. I'm going to inspect that traffic. Even if I trust Adam, right? I'm going to take a look at what he's sending. And maybe you want to move some of this left, a little leftwards in the request. Move it away from the origin. Maybe we need to put it at a location at the edge, right? And we can do this leveraging Lambda at the edge, a function that we can put out at our points of presence to execute logic, right, away from our origin. Again, Adam makes a request through my CloudFront CDN, right? But he's not logged in. So I can redirect him, in my case, to Amazon Cognito. Right? I can also use, again, a NoIDC compliant IDP. He's going to authenticate himself, and in return, we'll receive a JSON web token, or you call it JOT. Right? And he's going to put that right in his request. And I'm going to code or embed logic within my Lambda authorizer here to decode that JOT. Right? Make sure that he actually belongs to a user pool in Cognito that's authorized to access private content. I'm also going to verify, right, the signature on that signed JOT. Make sure that it's coming from an authorized, trusted source, Cognito in this case. Right? And maybe we don't want to give Adam the JOT directly. Maybe you want to work with that authorization code. Right? We can do that here. It's a bit more of a sophisticated process that requires additional work in the Lambda to communicate to Cognito or to an IDP. Right? But that's also possible here. But maybe, again, you're kind of looking at this and saying, well, CloudFront's great, internet gateways are great, but I work at a higher impact level, right, than they can really be leveraged, right, for CloudFront. Maybe I'm back to kind of my old enclave here. This ingress-egress VPC might be connected to site-to-site VPNs. It might be connected to a WAN over Direct Connect, right, for private connectivity. My compliance requirements may require me to do that. And instead, right, I want to just manage that ingress-egress VPC and apply like a software-defined perimeter and a gateway. Where I can establish micro VPNs between clients and gateway and resources on my back end, and then integrate with a policy decision point that's going to decide, right, what level of risk are we willing to accept? What endpoints will we provide access to within this enclave? Okay. In addition, we can maintain some of those boundary protections, right, that you're familiar with today. But in this case, I might say, look, I have an agent installed on device B. I understand quite a bit about the operating system, the browser. I also know that the subject, the user, is authentic. I'm going to allow them broad access to this environment. But I may also have a BYOD policy, right? Bring your own device. And less is known about some of those devices because I don't have an agent on that. Maybe I'm peeling off certain bits of data from a request, but I'm less assured about the relative security of that endpoint. So I'm going to limit my exposure just to VPCA. And I kind of want to tie this back to that macro segmentation piece, right? We're thinking about some of these VPCs and maybe their relative risk tolerances. And thinking about, again, how we actually segment out at a macro level, right, our routing here to prevent lateral movements from A to B. So I've walked you through some of the technologies, some of the thought processes for macro segmentation. We're going to pull out a bigger magnifying glass, so I'm going to hand it back to Adam, and he's going to really take us on a deep dive of what we can do inside the VPC once we're moving past the macro segmentation and getting into the micro.
Yeah, so as Forrest stated, we've kind of spent a lot of time on that outside perimeter, right? We've been outside of the VPC boundary, and that's great. Again, one of the concepts that is kind of the idea that hasn't worked very well is people they think the zero trust and they're like, okay, it's new, it's different, defense in depth is dead, but it's not. It's a key component of this aspect. And so as we've worked our way out we want to make sure that we're adding different layers of security along the way. Because again, it's not the crunchy outside, not the soft inside, it's the crunchy from beginning to end. And micro-segmentation is where we start to take those concepts and we bring it into the VPC and we start looking at our workload and thinking about how we can implement zero trust principles and practices there. And we talk about microsegmentation, we're talking about this like proximate workloads. We're getting down to like a very granular detail. You know, we're getting down to the individual server, down to the individual pod hosted within a container orchestrator on an individual server. We're like getting down very deep into the details and then thinking about different zero trust patterns and practices that will help us secure that particular segment of our network. And the one that I talk about, and people always look at me like I'm crazy, is the most fundamental building block of zero trust on AWS from a microsegmentation perspective is the good old-fashioned security group. You know, if we want to talk about it in interesting terminology, they're dynamic software-defined micro-perimeters. They're very small. They're not just a route table. They're very small firewalls that give us the ability to do things like programmatically chaining each other together. They're stateful, they're host level, and they're flow aware. And we can start to do things like say, hey, my application load balancer security group is only allowed to talk to my web security group for my employee directory. And my web security group for my employee directory is only allowed to talk to my database security group. These things are defined and chained together. You're not saying this individual server, this individual IP, you're defining the security group from aspect to aspect. And then by default, what'll happen is if my web security group tries to access another security group within my VPC that's not authorized, that request will be denied. This is a really powerful technology. It's got amazing performance, and it's free. And if you use security groups at a very granular level within your environment, that east-west and that lateral movement starts to get very, very difficult to do because now I can't go from one server to the other. And again, the great thing is security groups are really resource agnostic. So if I have an autoscaler, and I want to have one instance or I have 20 instances, they're all a component of that security group, and the IPs associated with them become less important. We get out of that like IP allow listing and getting into some more programmatic things. Like this is a very important way, and as we look at how we can do this at scale, we have some different tools to allow us to do this. In our commercial regions, we have prefix lists right now, which gives you the ability to broadly define IP blocks that are in your allow list, IP blocks that are in your trusted kind of list, and then you can put them into these security groups as rules. So if I look at the ALB security group for either of these applications, I can use one prefix list that defines my known trusted networks. I can put it in there, and then as I add IPs and I remove IPs, that automatically flows down. I have other capabilities like Firewall Manager, which allow me to define rules for my organization for what security groups are and are not allowed to do to prevent things like that quad zero thing that quad zero rule that Forrest was talking about. So we love security groups because of the granularity they deliver, and we're going to talk a little bit about how to think about them in a minute in combination of like different resources. So we have a white paper out on security domains, but what it fundamentally boils down to is we want to minimize the blast radius of our environment wherever possible. We want to make everything as granular as we can. Again, we're talking about micro-segmentation, very tiny things. So the first thing I want you to start thinking about is these resources are very granular. I said the security group needs to be mapped one-to-one, and that's true. If I have a particular security group for my web servers, that's that. But another corresponding aspect to that is identity. If I'm going to go that granular on my network controls, I need to go that granular on my identity controls. So if it's to the point where it would need its own dedicated security group, it also needs its own IAM role. We're starting to get this really small, minimize the blast radius, and be as specific as we can when we're allowing things to do things. Our next layer, our belt and suspenders, is we're going to try and be very granular in our subnets. We don't want to have one flat network that everyone is able to reside in that just has a local 10.0.0.0/16 route table. We want to segment these and use this as our backup to our security groups. If you have a misconfiguration, you want to be able to rely on things like network access control lists that are mapped one-to-one with your subnets to provide those suspenders as well. Like it's, again, defense in depth, fundamental stuff, but this is what we need to do to make sure that we're providing the exact outcomes that we want on AWS. And then as we move up a little bit more, we want to have one VPC per account and one VPC per resource. You know, I kind of cheated on that last diagram where I had two different dissimilar workloads residing within the same VPC. That's not a practice that we want. It should be to the point where each application has its own VPC, and then we handle the routing between them through different means. And we also want to start thinking about like the account mapping. We really want to have one account per environment per workload. So no longer is it that account A is for application A, dev, test, and prod. Now we have account A for dev, account B for test, account C for prod, et cetera. This starts to really reduce our blast radius. It starts to really reduce the opportunities for misconfiguration, and it gives us that micro-segmentation that delivers the security outcomes we want. Like, this is starting to get really defense in depth, and the thing that enables this, for the most part, is the advent of AWS organizations. Because now we can manage all this stuff at scale. We're given the tools to be able to go in and define policies that'll flow down and define them per environment, and then manage these things through organizations with firewall manager, config, et cetera. So if we do this, we break it all down, we have different, now we have a new problem we've introduced, right? We've now have two different VPCs for two different resources, and we need them to talk together. And Forrest went through some great macro segmentation ways to do that when we're talking about transit gateway, VPC peering, et cetera. The way I talk to customers is when you're thinking about how to connect these applications together. We had our direct employee directory app and our HR app. The thing I talk to customers about to try and think about doing it differently is to use micro segmentation to do it. Because transit gateway is great and it has its use cases, but there's an opportunity for misconfiguration, right? If I misconfigure one of those attachments, I can inadvertently cause the ability to route traffic from dev to test to prod or prod to prod. You know, there's some networking aspects there that you just can be difficult. And so I talk to customers about using AWS Private Link, which is a technology that creates narrow one-way gateways between two different VPCs. You instantiate a network load balancer in your provider VPC, and then you expose that network load balancer in your consumer through the Power Private Link on the back end. And it provides isolation between those two VPCs. If I want to initiate a traffic flow, it has to be initiated by my consumer. My provider has no ability to initiate a flow back into that consumer. It also allows me to do a neat thing where I can go one to many, and I don't have to worry about CIDR collisions and things like that. If you've configured Transit Gateway, you know one of the limitations is that you can't have overlapping CIDR ranges in those route tables. It's not going to do that network address translation for you. Private Link will take care of that. All of your consumers can reside in the same IP space, and Private Link does a translation on the back end. This provides a super narrow way to expose only the resources you intend to your consumer, because that load balancer on the right-hand side, you own that load balancer, and you own what it's allowed to talk to. And another component of this that's great with Private Link is it's instantiated in that consumer as a VPC endpoint with a corresponding security group. So again, getting back to the idea that if my web directory needs to be, my web server needs to be able to talk to that other VPC, I can use security groups to specifically allow that flow from web to the other cross service and not allow, for example, the ALB or our app tier or our database. All these things work together to create these layers of security that start to really deliver for your environment. Another aspect of Private Link that I really like is, if you're aware, we have VPC endpoints that are powered by Private Link. And this is the service that you use to gain access to AWS resources from your private networks. And one of the coolest things about VPC endpoints powered by Private Link is these VPC endpoint policies, which is now I can start to fuse identity with network access. So I have an endpoint that's going to be able to access services. Say it's S3, it's Dynamo, it's Systems Manager. And I can apply a policy to that endpoint to start to put identity constraints that can be enforced on the fly. So, and one of the coolest things that we recently released in the last month are these new conditions that you can apply to these endpoint policies from an IAM perspective. So now I can put policies on a VPC endpoint that do things like restrict access to resources that are only owned by my organization, that are only owned by my account. Or I can put policies on my endpoints to do things like you can only access this endpoint from an identity owned by my organization or my account. So, and then on the other side of the equation, I can put access policies on my resources. And so the full belt and suspenders when we start thinking about this is if I have a bucket that I want they have a very specific need. Maybe it has PII, maybe it has sensitive data. On that bucket, I'm going to put a policy on it that says, hey, you can only access this bucket from this particular VPC endpoint or this particular VPC. And then on that endpoint, I'm going to put a policy that says the only bucket that can be accessed is one that is the one that I intend, and it has to be a member of the resource that you're accessing has to be owned by my organization. So there's all these belt and suspender aspects that you can do, and now I've got this super secure way to make sure that my identities are accessing my resources from my networks. And I'm not worried about, for example, my identities accessing other people's resources from my network, because that's the concern, right? We're worried about people accessing buckets from other buckets using VPC endpoints. And now we can granularly restrict it and do it at the organization and the account level. This is a super powerful thing, and I highly recommend we release a white paper that talks about security perimeters and how you can use things like this to talk about that resource, identity, network components. The next piece that I'm going to talk about that's a little bit more different when we think about microsegmentation is mutual TLS. This is an interesting component of microsegmentation because it's really an application level concern. If we use mutual TLS, which is the ability to authenticate both the server from their certificate and the client with the certificate contained by the client, we're now starting to, one, provide encryption in transit and also provide identity with it. You have to possess a certificate that has been actually authorized by my certificate authority. And this has been long used in the DoD and in the public sector related to smart cards, and it's been kind of the way that you do Internet of Things devices. And we have two different services that specifically support mutual TLS that then use that to integrate with other AWS services and capabilities. The first one is API Gateway. Not a lot of people are aware API Gateway does support mutual TLS authentication. What that does is you can now present your client certificate. One, that client certificate is authenticated as valid against your certificate authority that you've already entered in. And then you can write a Lambda authorizer to do authorization rules based off of that client. So you might have a DynamoDB database that's going to have a list of user groups or users that are allowed to then get access so that you can get more specific than just at the CA level. And then that will then grant access to resources on the back end, like API, like your Lambda functions. The other service that uses MTLS is very common is our IoT services. In this scenario, we actually can manage the certificate authority on your behalf. So there will be a root CA that will be owned by AWS. We'll issue device certificates that you then load into your devices. You can use things like Amazon Free Real-Time Operating System, or RTOS, to present those certificates from the IoT device to IoT Core to gain access to AWS resources. Again, now we have security in transit, we're fusing in identity, and if we want to think about zero trust, we go back to that continuous diagnostics and monitoring piece. And the thing that allows us to do that from an IoT perspective, and we talked about them being an important consideration, is IoT Device Defender. I can use IoT Device Defender in order to take my resources and then say, hey, is this acting abnormally? Is it not acting correctly? And then take actions based off of that. Mutual TLS is an important component of my next one, which is I talked about the fact that we did a lot of networking talks here and a lot of networking strategies. But where the network starts to fall apart is when we talk about containerized workloads. If I'm running workloads on ECS or EKS, I may have two different workloads that are going to exist on the same host. And they may talk to each other exclusively through the host local network within our container orchestration system. So how do security groups work there? How does the endpoint policies and all the things I've been talking about? These things start to become more difficult, especially when we talk about scale. It's easy for 3, 4, 5 containers, but it really starts to grow as you grow your environment or you start to do complex things like bridging networks, bridging VPCs. And the way that we really like to think about a good option for zero trust in these containerized workloads is service meshes. And what a service mesh is a central control plane that's going to exist within your network. And usually it's going to be providing some of the brains. And part of that is it's going to provide these policy enforcement points in the form of a sidecar proxy. And that's a container that's going to run alongside your workload, and it's going to proxy all the traffic from your pod or from your workload in and out of the network. And then those sidecar proxies, when they want to make a call, so if workload A wants to talk to workload B, One, they're going to use mutual TLS with certificates issued by that service control plane. And then two, they're going to look at the policies potentially that that service control plane has available. There's several different projects that will allow you to provide a very granular way of describing that language. If A is allowed to talk to B, but not allowed to talk to C. And those sidecar proxies will enforce those rules and that micro-segmentation. So even if I'm not hitting my network, if I'm not hitting my VPC, I'm still able to enforce that micro-segmentation of my workloads within my environment. This is a really important piece. Again, containers are such an interesting space right now. The DoD, the federal government's very interested in them. And we have to find ways to accommodate containers in our zero trust architecture that can be managed at scale. So that gets us through for the most part for micro-segmentation. This is a high-level overview of some of the AWS services we've talked about and some of the mappings that's associated with them. There's a couple that we didn't get too deep into. Our AWS Cloud Wide Area Network, that's a great capability that gives you the option to do some of that software-defined networking at scale. Private 5G to do micro-segmentation or macro-segmentation of your network locally. And then Route 53 can do some interesting routing things as well. But we kind of went through a lot of different services. We talked through a lot of different things. If you're not familiar with any of these, please take advantage of the different skills trainings available. We also have certifications that are related to it. Forrest and I thank you so much for coming out to our talk today on Zero Trust, and we'll be available after the session for any questions. So.